Hello, everybody. This is Nick Latero, Professor of Information Technologies and Computer Science, Lakeland Community College. I routinely get asked the question, why do we require our students to take programming logic or learn a programming language? And normally I will give the answer that regardless of what direction you're going down in the ITCS world, the knowledge that you acquire, the methodologies that you acquire, the tools that you acquire in programming logic can be used in other areas. You may never write a piece of code in your life, but the methodology, the logic involved in taking a problem, breaking it into small components, and then doing something with it, that is what programming logic is. But then there are times where even if you're not a coder, you may have to write code. So in this video, we're going to explore writing code. Now, we're not going to worry about the logic. We're not going to worry about the syntax and the nuances and things like that. We're going to write some code. And probably the level to write this code is the level that we would acquire in programming logic, or it could even be a level that you just began to write code on your own. You grabbed a textbook or you grabbed a book, you looked at YouTube videos and you say, now it's time to write some code. Now, before we do that, we have to have a little bit of a scenario. So we're going to build a story. I'm going to build a story here, and this is the direction that we're going to go. So the direction is that you are given a flash drive. You are working on a forensics case. You're working maybe with law enforcement. And law enforcement says, we found a flash drive. And on that flash drive, we suspect there is, I'm going to be graphic here, we suspect there's child pornography. Now, the reason I chose that topic, it's disturbing. I completely understand that. But whenever they suspect that there is child pornography on a device, they have to be extremely cautious. They cannot copy it. There are procedures involved. They can get what are called hash files, and we'll talk about that in a second, but they have to be extremely cautious. They cannot copy that. Now, they can create images of the file, but they have to be very careful about opening the file and who controls those images. It's very important. So I understand for some people this is a very sensitive subject, but because of the extreme nature of it, how it has to be handled, I thought it was important. And one of the things in forensics that we use are what are called hash values or hash digests or hash digits. And what a hash value is, a hash digest is we can take a file and we can say, calculate what the hash digest or hash value of this file is. It's a one-way process. It is not encryption. So it takes a file, it runs it through an algorithm, and there's different algorithms for different hash values. And it comes out with a fixed length number, normally in hexadecimal, that becomes almost the fingerprint to that file. It cannot go backwards though. We can't take a hash value and go back and find the original file. So I can take the entire content of War and Peace, grab a hash value from it, and if I change one bit in that document and I rerun the hash file, the hash digest or the hash value is different. So it's a way of guaranteeing that that file has not changed. It can also be used as almost a form of a dictionary. And what I mean by this is, again, going back to you have an inappropriate image on a file. We don't want to open up those files. They become very disturbing. So how can they go hunting for, how can a forensics investigator go hunting for those files without really opening them up? Now, sometimes they have to. Well, a lot of times, sadly, these criminals share these documents with each other. They share these images with each other. And over the course of time, law enforcement keeps a list of the hash file the hash value of those files. They do not keep copies of those files, but they keep the hash value or hash digest of that file. And that's just a list of numbers. I'll show you one when I start doing demonstrations. And it's just a list of numbers. And since it can't go backwards, they can't recreate the actual document. So it's a safe way to go hunting for these files. Now, sometimes they may have to go looking specifically, open up these files. And those are very special individuals. And I don't want to go down that path. So we're going to go under the approach that law enforcement gave you a flash drive. They suspect that there is inappropriate images on this. They don't want you opening up the images. That's for an investigator. There's a lot of tools we can use, but they've given you a list. They suspect, they really believe, based upon other things, that maybe there were 3 documents on this, and they have the hash value or hash digest of those documents, right? They're not going to show you the documents because maybe those, or give you the name of the document because maybe those names change, but they have 3 values. Now, what do? Well, there are things that need to do in the forensics world. And if you're interested in that, we do teach a forensics course here, or you may be taking the forensics course here. But let's go through that. We've done everything that we're supposed to do in the collection of the data. But now it's time to go hunting for those particular documents. So we took some pretty big steps here, right? One of the ways that we can hunt this is kind of unofficially, we could write code to do a really quick look at if those files are out on that drive, right? Yes, there are some very sophisticated code that we can use or programs we can use, but we want to see real quickly, can we get a list of all the hash values of all the files on a drive and then compare that with the known hash values of some of these inappropriate things. It'll make more sense. I know it sounds obvious. It's going to make more sense as we build upon it. So the best thing to do now is to go up to my screen and let's discuss how this can be done. All right, I'm going to write this code in Python. Python is a great programming language for automation. I'm going to go step by step of what I'm doing. I'm not going to worry specifically about the logic, all right? That's a different subject. What I'm curious about is there a way for me to do this fairly fast based upon a beginner's level or even an intermediate level of programming logic? Now, there's a couple things we have to be aware of this drive, all right? So we start with, what do we have to do with this drive? What do we have to do with this drive? Well, one thing we can do is not automate. We can go through every single file on this drive, or what we would actually do is take an image of it, but we'll say, I can go through every single document and I can run a hash calculator against each file. And just so happens that I have a hash calculator available to me. And what I would do is I would bring this up. I would not do this, but I would bring this up and I would find each file and I would go to each file, I would open it up and say calculate. And there are the hash values for those files. Now, obviously, I'm being a little facetious here. Would I use this tool in an individual file case or maybe 2, 3, 4 files? Absolutely. But if I had to do this, let me see if I can stretch this out. If I had to do this and go through literally hundreds of files, some of them hidden, some of them buried deep down into the file structure, it would be very difficult. Right? It would be very, very difficult. But the reason I brought this calculator up is that you can see I looked at a file, I said calculate the hash, and it gave me a series of hash values for MD5, SHA-1, SHA-256, SHA-512. Those are the numbers I'm looking for. If I was to go into this file right now and change 1 bit, not even a byte, change 1 bit and recalculate it, these values would be different, right? So kind of a little bit of a backstory here. These files would be different. But I couldn't do this, or I wouldn't want to do this with hundreds of files on a given, or even potentially thousands of files on a given flash drive. So another method I could do, I'm not going to open up, is I can open up a very specific software, Topsy, which would allow me to look at the image of a file and it will do all the calculations. It will look at very specific things in the file. It's a very detailed orientated program, right? It's a fantastic program. We use it in the forensics course all the time. But I'm just looking for those particular files, right? I want a quicker way, just kind of an informal way. And then maybe through the informal way, if I discover that, yeah, those files potentially are on this, I strongly suspect those files are potentially on this flash drive, then I would open them up with another program. So how would we do that? We would do it through automation. What I have here is a Python program. Again, we're not going to worry about the logic. It's a Python program that basically is going to go through every file in this or on this USB drive and hash it. Now, let's think about that before we go any further. Let's think about it. I'm going to make it just a little bit bigger. I paused it so you didn't have to worry watching me make it bigger. All right. What do we have to do? And that's one of the first things we do in programming logic is analyze the problem, sometimes called system analyze the problem, but analyze the problem. Well, there's a couple things. One, I think most of us understand the file structure. So I have to find a way to navigate down each directory, each subdirectory, and each sub-subdirectory as far as we can go, right? So that's one thing we need to do. We need to then grab those files and hash them individually, and hash them with different hash algorithms, MD5, SHA-256, SHA-1, SHA-512. So we have to navigate down every file and then calculate the hash values based upon the different hash algorithms. Okay, finally, or not finally, the next big thing we would have to do is kind of put those into a file. Put them into a structured file that we can then look at. The hash values with the names, the hash values for the different hash algorithms we're using, and we put those in the files. Now, normally, or probably one of the most commonly used structure to save data for potentially put it into an Excel spreadsheet or put it into a database is common separated values, right? We see that a lot in a lot of areas. So those are three big topics that I would like to cover. One, navigating through this USB drive. Two, hashing each file one at a time with the different algorithms. And then three, take those hash values and put those into a comma separated value so I can then use it. So let's start there. I don't want to reinvent the wheel, right? It doesn't make sense to reinvent the wheel and go in there and code everything from scratch. Now, this is the important part, one of the important parts of this video. Somebody somewhere has probably created some modules or libraries that would allow us to do that. Now, I'm not getting into the specific of modules versus libraries. You can look those on your own. Basically, a library is a collection of a whole bunch of different modules and different tools, and a module is usually a file, a PY file that in Python that does certain things, right? So we're not going to go into the real big differences between modules and dictionaries. Modules and libraries. Apologize for that. So somebody somewhere has created modules to probably do what we want to do, right? And that's an important subject. The world has really been built lately on open source or open availability of these tools, these libraries. People wake up every day saying, I want to improve X. So one of the things that I would do is I would go out to the internet and start looking for certain libraries. And I want to make sure that those libraries are tested and validated through Python and the Python organizations or whatever programming language you're using. You just don't want to go out there and just start looking at things. So I start doing some homework on the internet. That's big. I start doing some homework on the internet. It says, give me a Python module that allows me to navigate down a directory tree. You know what? Let's do that. So I'm going to go up to my screen. I'm kind of cheating here to expedite things. I understand that. I would do some searching. But basically, I'm going to go up to my screen. So let me go up to the screen. Sorry. And I would do an internet search. And sure enough, there is a library or a module called OS, Miscellaneous Operating Systems Interface. And what this module would allow me to do is navigate down through the different directory, and they would give me examples and they'd give me explanations, etc. I would do the same thing with hash values. I can go, okay, I want a Python module that hashes files. Oh, there's one, hashlib. Okay, so this is secure hashes message. If I do some scrolling through this, yeah, it's going to allow me to hash individual files through Python. So I've covered two of the bases. Okay, I can navigate down the operating system. I can hash. How about saving something as a common separated value? I do the exact same thing. I'd say Python, comma, separated values, and we'll say module. All I'm doing is doing some searches. Oh, and there is another one. You would be shocked the number of libraries out there that are safe, that have been tested. You know, you want to be careful with that. You want a safe and tested library, but if it's coming from the Python org, it's probably a really good chance. And sure enough, there is a module that allows me to, that has a whole bunch of methods and functions that would allow me to save things to a common separated value file. All right, so we've made some progress. And that's what I have here. This is the module introduction into my program. So the first thing is, many of these modules are very large, right? And we may not want all the tools that would be associated with there. We want to keep things down to something that our program would be fairly easy. We wouldn't see that, but it could put a strain on the CPU. So many times we say, okay, we only want certain methods, certain functions, certain capabilities from those modules. So this first module, it says from OS, that's a module, import just the walk and path. And what that is, OS walk generates a file in the names of the directory tree by walking down the directory tree or walking up the directory tree. So there is a method that basically says, navigate down or up down the directory tree of this USB drive. And then OS path, common path, path name manipulation allows me to do things with the given path. So I have checked the box of saying I have to be able to navigate through this USB drive. The next one, import hashlib. Now we're going to be using a lot of hash, so I said, you know what, I'm just going to import everything because maybe down the road I'm only going to use 4 hash algorithms: MD5, SHA-1, SHA-256, and SHA-512. Right? I'm only going to use those. So, little typo there. It's just a comment, so it won't make a difference. So I'm going to import everything. Okay, I'm okay importing everything. If I was to do some homework on that particular module, it's probably not that big of a module, so I'm pretty safe there. And then finally, the CSV, all I need from the CSV module is the writing capability. So again, I take the approach of from CSV, import writer, right? I'm being very meticulous about what I am using and what I am not using. Okay, that's important because again, we don't want to overwhelm our CPUs and stuff like that. And again, this is more of an ad hoc process. This is not an official process, an ad hoc process to kind of work through there. So in programming logic, we learn about modules, we learn about libraries, we learn about using them. Or if you're watching this in your programming, this is the introduction of modules. Alrighty. Now, I know this stuff looks really, really complicated, and I'm not going to go down the logic. This is basically what we would understand by taking a programming logic course. But basically, I'm going to create a function, right? I'm going to create a couple functions. Well, in this one, I'm only going to create one. And one of the functions I'm going to create is something called calculate hash, and I'm going to pass it values. Well, as I grab a file, I'm going to pass it up to the function called calculate hash. So I have to give it the path name of the file. That makes sense. What file are you going to be working on? The full path name to that file. I then have to give it what hash algorithm you want to use. Now, in this example, I'm going to pass values. If I don't pass any values, the equals SHA-256 just says, if I don't pass you a hash algorithm value, default 256. I'm sorry, my screen keeps popping up like that. And then chunk size. I can pass it up a chunk size. I'm giving it a default value of a chunk size. You'll see me not really passing up the chunk size. And what the chunk size is these files that you're going to be hashing can be very big, all right? So hashlib oftentimes cannot look at the entire file itself. Can you imagine trying to get a hash calculation from like a 2 gigabyte movie drive, a movie file? It's possible. It's doable. That's not the point. The point is, if I take that 2 gigabyte file, I say, give me a hash, the hash calculator is going to just get overwhelmed with it. So what it does is it breaks up that file in little chunks, calculates, grabs the next one, calculates again, grabs another chunk, calculates it again. So it keeps on updating the hash value based upon these chunks that it's grabbing. It's just a more efficient way for this tool to use. So again, file path is the name of the full path name of the file. Hash algorithm is what hash algorithm you want to use. The default would be SHA-256. The chunk size is how big of a chunk of the file do you want to work at a time, so not overwhelming the library, overwhelming your CPU. And I say, okay, the default is 8,192 bytes at a time. So it can take some time, especially this is the normal process. Alrighty, and then again, not going to worry about the specific logic involved here, but we can go through it really quickly. The with open basically opens up the path and some other things. It basically goes out there and starts looking at these given files. Here is our chunk size, and then if you read this, so read the first chunk, and then keep reading chunks until there's no more chunks. So this is just a while loop that says keep getting the next chunk at any point that while the chunk that you're grabbing is greater than 0, keep calculating. If you get to the point where the chunk is equal to 0, then you're done calculating. And this line here, update the hash value. Remember what I said, that as it's grabbing chunks of code, it is calculating it and then constantly updating this. And then eventually it just keeps on going out and reading the file in chunks of the next chunk. Eventually it is going to return the hash value. Now stop here for a second. A little FYI. I wrote this code myself, right? I did this code a few years ago, but could I have done this code with artificial intelligence? Could I have done it with ChatGPT? Absolutely, all right? I would document that saying, this code was written with ChatGPT, but I still, as the programmer, would have to manipulate it and put it into the areas that I wanted to do. So using a ChatGPT in this particular situation makes absolute sense, right? I'm just giving a full disclosure. This particular program, this hash calculating program, I wrote myself, right? But If you don't want to get down into the weeds of the whole nitty gritty little logic involved, oh yeah. People routinely go to ChatGPT and say, okay, write me a function that does X. And it'll come back and write you a function that does X. You put that into your code. As long as you're documenting that, as long as you're making sure that people understand that. But this one I basically wrote. So we have this hash calc, and then we run the code. So before we start running the code or talking about the main, we went out and we did research on different libraries to do something. So our analysis of the task was we needed to navigate down the USB directory. I found a library to do that, so I don't have to reinvent the wheel. I needed a library. I needed something that would calculate the hash values. Well, I found a hash library, hashlib, so I didn't have to reinvent the wheel. And then I said I wanted to write this into a common separated value file so it would be consistent. Maybe I can load it into a database or load it into an Excel spreadsheet. I did not want to rewrite the code or reinvent the wheel, so I found a module or library to do that for me. And that's one of the big gist of this video is we're automating the process. We're using libraries from someplace else. If you wanted to use an AI to accomplish most of this task, you could do that. And then we kind of massage the programming. All of this should be able to be accomplished after a programming logic course, especially if you take it with me. No plug there. I wrote a function to do the calculations. And now it's time to run the code. Let me break down what is going down in this main down here. First of all these lines right here, these first three lines say, I'm going to create a common separated value file. We're going to call that file right here. We're going to call it file hashes.csv. Don't worry about the W means you can write to the file. New line means after every individual write, add a new line. This is the writer object constructor. Don't worry about that. That's more has to deal with constructions and things like that. And then the very first row that I'm going to write is in my document. I have to tell the CSV, what are those columns? What are those rows? So the very first row is going to be more of a description. You'll see that when I run the code and we look at the specific CSV file. Then where do you start? What is the starting point of the navigation? Right? Where do we start on this? And the starting point is the top of D. So I'm going to plug this USB drive into my machine, and then I'm going to scan it. Now, in a real forensics environment, I would do that to a disk image, right? But we're suspending reality a little bit here. And here is basically a loop. We start with this loop that says, starting from the root directory, work your way down, and that's what top down means. Top down true means start from the top, work your way down, and go through every single file. So one line says walk through, and that's what walk does, walk through this drive and return back to us the root and the directories, put them into a list here, a list called files. All right. Now it's time to, once that is done, so basically it went and it created a list. It created a list that of all the files here. Then we get into the guts here, right there. It says, okay, let's go through that list and let's do some calculations here. And it says for every file in the file list, you're going to, now this print statement here, that just means print it to the screen, right? Kind of like a little bit of feedback there. File writer, right? Write it to the file. What am I going to write to the file? Well, the first thing, this right here says, and it'll make more sense when we get to the CSV file, write the file name, the full path, and the file name that you're working on. That's all. Finally, we get to calculate. We get to calculate the hash values. So it says, okay, this is the full path and the file name right here. Calculate it. So I say, calculate hash. That's the function that I created. and basically calculate. Join means, like we said, join just says take this path, take this name, join them together, and calculate based upon MD5. So I'm passing up those things. You notice I'm not putting the chunk size because I'm just going to leave that as default. And I do that with MD5, SHA-1, SHA-256, SHA-512. So it's going to do it. It's going to create a line inside, not create, it's going to create a line for every file, but in that file, it's going to be comma separated all the different hash values. So quick repeat. We go starting from the top down, we look at every file that basically creates a list. Then we, from that list, right, we grab each entry in that list and we basically give it a full path name and a file name, and we say calculate away. Now I'm going to run this program and I'm going to skip a couple, not steps, but skip some time here. There's a lot of files here and hashing takes time. So I'm going to start the application, I'm going to let it run, but while it's running, I'm going to open up the file that I've already created, right? So let's run this. And away it goes. And you can see right here, it is going through every single file on that USB drive, even the ones that are hidden. Now, I didn't do it with here, but other programs, I can look for deleted files. I'm not worried about that right now. So anyways, it's going through, and you can see that it's taking a little bit of time because if they're very, very large files, it has to chunk them and it has to update those. So it's going to take some time. So let this run, but I've already run it before. Let's take a look at what the CSV file would look like. Very small files take some, real quick. And here is the CSV file. So in the CSV file, which I can open up using Excel spreadsheet or import it into a database or just open up with a text document, you can see that I use certain graphics on my computer. The file names are represented in this orange. So any place where I see orange, that's the file name. There's the comma separated. MD5 hashes are in red. SHA-1 hashes are in this, I guess, magenta? I don't know colors. SHA-256 are kind of in this aqua green, and SHA-512 are in white. So as I'm looking at, here's all the hash values, or sometimes I call them hash digests of these files, right? It's going to go through all of them, the entire drive. So how many files did it hash? Right here, 817, right? Did not open them, it just hashed them. Now, let's say, going back to our scenario, law enforcement gives me these hash values and says, if you find a file that has these hash values to them, we know from past experience, those are inappropriate pictures. They are criminal activities. So all I have to do now is look for those hash files. I would not have to go through, and open up. Now, they would have professionals do that. But at a minimum, law enforcement has a record of all these hash values that says, you know what, we've discovered in the past cases, these particular inappropriate photos, images, and these were the hash values that were associated with them. Can you tell me if those images are on the drive? Now understand, it's absolute. It is going to be absolute. If those photos are on this drive and those hash values are present, absolutely, that file is on that drive. Absolutely. Because remember I said, when I hash a file, if I make one change to it, it would change the hash value. So if I discover those hash values, they're on the drive. So all I would need to do here, I'm going to move this over here. Here's my file. All right. And I'm going to take the first hash value from that little, I'm going to say find me. I'm going to say find this hash value. And boom, found it. I now know that particular file that the 200 43rd file is that image file. So if we look at it, Saturn V, rocket, images, LH2, pipe, scale, JPEG, right? They're not going to give you a file name that is real, right? Inappropriate pictures, naughty picture, things like that. They will rename them, right? But the hash value tells me the bytes, the bits, the bytes, everything in there tells me that that file is the file that we're hunting for. So let's do another one. Again, all I'm doing is copying and pasting from that notepad. Does this one exist? Yep, that one exists. So it's sad, but basically we found another file that is a well-known inappropriate file. All right, we can start building a case. Now, what I would do, obviously report to the police, we would run it through the other programs and then we begin to open it. Autopsy is the one that I was thinking about. Let's look at the last, let's hunt to see that last file. No, it didn't find that one. Okay, that's fine, right? But we did find the other ones fairly quickly. Let's wrap some things up. A little bit of a long video. I understand that, but we had to cover a lot of things here. We covered forensics. We covered ad hoc programming. We covered modules. We covered libraries. We covered logics, hash values. So a lot of things in this video, but the most important thing I think about this video is in our programming logic, we learn the fundamental philosophies, methodologies, whatever you want to call it. But then there comes a point where we can apply that knowledge and programming becomes an applied tactic. We use it in other areas. We use it in forensics. We use it in ethical hacking. We use it all over ITCS, right? So I came up with a subject. I came up with an idea of I need to scan, and we found out there was over 800 files on here. I needed to get hash values, multiple different hash values for the same file, and then go looking for it. I did that with a automation using a simple Python program. Now I can dive deeper, right? So this was like a little preliminary step. Okay, we found those files. Let's go. Then we can tell law enforcement if we're working with law enforcement. All right. Long video. I hope you enjoyed it. These things happen all the time, not the criminal justice, but the creating ad hoc programs to go out there, do something for you. So that being said, let's go and learn something.